So I'm Paul Nash. I'm the product lead for Compute Engine, and I have with me today Michael Crandell, CEO and founder of RightScale. He'll be up in a little bit. So today we wanted to talk about Google's approach to cloud pricing in general and how we think about customers and what we try to optimize for in building products. And then specifically for Compute Engine, we want to talk about the customer-friendly pricing features that we've come up with that we think are really a great way to use the cloud. Then we're going to talk a little bit about how beyond that set of features and discounts, there are some other things you can do to tune your workload to save even more money. And then finally, we'll have Michael up to show some real-world examples using customer data of what that looks like on paper. And then we'll take your questions as well, or you can all run away and have beer. I'm fine either way. So Google's approach to cloud starts with Google's approach to customers in general. And one of the things that I mean about that is we have a set of core values at Google about key principles like data security, privacy, and above all, user trust. So we believe that maintaining our users' and customers' trust in Google is looking out for their best interests as one of our highest callings. So additionally, our goal is to build products that are simple to use and well-designed, and this includes how you pay for them. So what that boils down to on Compute Engine is really three core pricing philosophy principles that we use to think about how we're pricing and how we're building discounts. The first is, it should be simple. So no rocket science, no PhDs in economics, no ministries of pricing within your companies, as was said this morning, and no hidden costs. Second, it should be flexible. And what that means is you pay for what you use. Apparently, the whole point of cloud is to be elastic, right? Well, some things are more elastic than others. And so for that to be true, the pricing can't rope the developers into a certain shape of what you're using or how long you have to use it for or what you can do with it. And finally, then, we think the real embodiment of user and customer trust is the idea that prices should be fair. So we should start with making prices low as we can. And then if we find ways to bring additional savings into the ecosystem, either because we're scaling or because we got better hardware or we found some new efficiencies in how our software is managing that hardware, you should get those savings passed on to you as well. And that includes also the concept of automatic discounts. So if you use the cloud in a way that is more efficient for us, we should pass those savings on to you. So what do I mean when I say simplicity? Well, this is a graphic that one of our product managers came up with. It's a little faded out, but this is a screen capture of our pricing page, sort of laid sideways, and one of the other cloud's pricing pages laid sideways. So it's a pretty obvious representation of like how much do you have to ingest and understand in order to figure out what's going on, how much am I paying? I spend a lot of time with these pages. I'm sure some of you have as well. They're lovely pages. But what I find is that I also spend a lot of time with Chrome's search in page feature to find where the information is on that page that I'm trying to understand. How much is a customer being charged for that? And it's not at all obvious that is a good use of my time. In fact, usually I don't consider it is. I usually end up building spreadsheets, in fact, to break that information apart and try to understand it more. Wouldn't it just be simpler if you didn't have to do that and you could focus on your application? That's what we think about. So one of the main ways that pricing can get complicated is in how various IaaS resources are bundled together by some of the providers. So this creates dozens of different pre-canned configurations, I call it alphabet soup, which are ostensibly optimized for different classes of workloads. And the problem is, as always, that requires a bunch of generalizations and a bunch of assumptions. What if you need all the RAM, but you don't need all of the CPU? Or what about that SSD that you got for free in that VM? Are you using that? Because it's not free. So understanding the basic combinations and all the sizes, that can be kind of a full-time job. And trying to figure out, for example, simple things like how much are you paying for one of the CPUs in your machine or for a gigabyte of RAM? It's hard to tell for sure, and it's not always the same. And what's worse, every time they add a new generation of hardware, you get a whole new set of SKUs to figure out. This is a problem we talk about internally called SKU explosion. So you have some giant page of all the different price points and how much everything costs, and every time there's a new discount model or a new tweak or a new feature, you get a whole nother set of those SKUs. It's difficult to manage, it's difficult to understand, and so we try to find a better way. So by comparison, we have one main family. It's called N1. There's a couple very special machine types called F1 and G1, but almost all of our usage and almost all of our customers are using N1. We might someday have a second family, but that's kind of a big decision for us. So we just have the one for now. And what we try to do with that is give you a transparent price and performance. So that allows us to have as few SKUs as we possibly can to understand in the first place. Fewer things to understand, the better. And with something like custom machine types, there's actually only two. There's how much a CPU costs and how much does RAM cost. So that lets you buy just what you need, and you can use it however you want, either as one of our predefined shapes or as a custom machine type. So with the custom machine types and the predefined shapes, we put some predefines in there just so that it would be a little bit easier to get started. So there's a couple typical ratios of RAM to CPU that a lot of customers will find adequate for most of their workloads, but you should just think of those as little marks on the dials that you can use to start. If you want to start there, that's great. If you don't, you can build a custom machine type. And either way, if you find later that you're not using the right amount of resources, you can optimize that easily. In fact, we even will help you do that. So a VM, at its essence, of course, is just that CPU and RAM. And anything else we view is an add-on. So another way that we try to keep things simple and transparent is by trying to not bundle in the different pieces together and giving you an opaque product that hides the different costs of those various components. So why do the others do it this way? Well, it's easier. But it's easier for them, not for you. So pre-configuring the hardware according to a fixed recipe, that would sure make it easier for us to manage our fleet, but it would make you inherit the complexity. So what would end up happening is that you'd pay the price because you're paying for things you don't need. And they'd all be bundled together in whatever alphabet letter you decided was the right VM for your workload. So we decided to keep our prices visible and let you choose what you need, and then we'll take care of the fleet efficiency behind the scenes using Google Magic. So just to give you an example of one of the things that tends to get bundled in on some clouds is how much does it cost to run Windows on a VM? Well, it turns out you can't really tell unless you go back to that giant long page and build a spreadsheet and crack everything apart. And once you do that, what you'll see is that depending on the alphabet letter that you choose, the cost of Windows per core is different. But that's kind of strange because the cost for us to sell you a Windows license per core doesn't change if we run it on a faster or slower CPU or on one that has more RAM or memory or disk attached to it. So on Google Cloud, it's always 4 cents per core per hour, no matter what. So now I want to talk about flexibility. And that really means these two concepts. So pay for what you use and buy only what you need. Sounds simple, right? Everybody does it? Not so much. So everybody assumes that cloud is pay as you use, but it turns out that the way that you count usage matters a lot in practice. So in GCE, we've had permanent billing from day one, because at Google, we understand that workloads don't come in hour-long chunks most of the time. So for example, imagine that you had a set of VMs illustrated just below by this bar chart that were running for differing periods of time. And there are a number of ways this could happen. One is that maybe they're part of an auto-scaled workload, and some of them are only needed for a small amount of time, and some of them are needed for most of the time that you're experiencing a spike. Another way that this might happen is if you're doing some batch processing and there's a number of different tasks being distributed to VMs, and you need some for a while and then others you don't need for a while. So movie rendering might be a good example of that, where you don't know what the frame time is going to be. Well, if on the scale at the left you have 0 to 60 minutes and your workload takes the amount of time in blue, then all of that stuff in the red is wasted. And in this particular hypothetical example, that's like 40% of what you're paying. So this is a slightly different scenario that we modeled to illustrate what would happen if you were using an auto-scaled workload. So in this example, the bar charts are representing a set of VMs that you have where every VM can run 20 queries per second. And let's imagine that this is a website and a talk show host, famous talk show host, has just mentioned our website on live TV, and we had this burst, and everybody wants to come and buy our widget. So in order to react to that scale, you're going to spin up something like 50 VMs. But here's the thing. When you go to spin those down, whether you spin them down right away or not, if you're paying per hour, you're still paying for another chunk of usage that's almost as big as the spike itself. In fact, looks a little bit bigger. If you're paying per minute, it scales down much faster as the traffic dies away. And this graph doesn't have to be blocky like it is here. This is just shown at 5-minute intervals to give you an idea of what the steps look like. But in reality, our autoscaler at least resamples every 60 seconds. So it would follow that curve much more smoothly. So finally, another use case that we see a lot. So imagine that you have a workload that takes about 4 hours to run, and it runs on a 4-core machine currently. Now let's say you go and do a bunch of optimization work, and you've got it to the point where you can scale up that workload, and you're getting about a 1.8x scaling factor. Could be 100, but it's not ever 2.0. If you want to double the number of cores, you're not going to usually get exact scaling. So let's say that you get 1.8x. So the graph on the left shows what the runtimes would change and how they would change if you went to 8 cores, 16 cores, or a 32-core machine under those assumptions. And the graph on the right shows what you would pay if you were paying per minute versus per hour. So what happens is the workload runtime might fall below one of the hour marks, but you're still paying for the extra waste. And so all of your work, you might have gotten your answer faster, but you're paying more for it too. So this is one of the key principles that we believe is important in a truly elastic cloud. So next I want to talk about VM sizes. So why is it that machines are sized in powers of 2 anyway? Anybody know? Anybody have an idea? I'll tell you why. It's easier. Again, though, it's easier for whoever's building the cloud, not for you, the customer. So the computer scientists in the room might recognize this. It's called a bin packing problem. And if you don't have powers of 2, the concern is that it's harder to make sure that all of the processors on a machine are filled and in use all the time without leaving some behind. Well, it turns out at Google, we solved that problem a long time ago because we built our cloud 10 to 15 years ago. And we have lots of workloads too, but we need to pack them all in efficiently on processors. And so we built a system called Borg that does that. It further turns out that when we went to go build our public cloud, we built it all on that same Borg technology. So underneath Google Compute Engine is years of work from hundreds of engineers figuring out how to solve that problem without making you just pay for the inefficiency. So if I sell you power of 2 sized machines, like a 64-core machine, but you actually only need 40 cores, the other 24 cores are wasted. If I'm the cloud provider doing that, I might not be concerned about it because you're paying for it. If I'm Google and I'm building that cloud for myself, I'm concerned about it a lot because I'm paying for it. And it's a massive amount of inefficiency. So we get rid of all that by offering you custom machine types which are built on that same infrastructure. Another advantage that we've seen from this is that a lot of customers over time have purchased specific sized hardware. And in an on-premise fleet, it's common to see something like a 12-core machine that's actually 12 physical cores. So if they want to move that to the cloud, today they'd have to buy a 16-core VM in a lot of places. And that automatically shifts the bill and makes the comparison of costs difficult. So if you have something like custom machine types, it's fine for a customer to bring their bill of materials, their whole list of all the different VM sizes and shapes that they have on-prem today. If they're thinking about lifting and shifting a workload, you can simply configure a custom machine type that matches those sizes, bring all your workload in, and then optimize when it's convenient for you. So we see customers do that a lot to get a better match between what they're going to use in cloud and what they're using today on-premise. In fact, we launched this feature just a little over a year ago, and in that time, it's grown to be about 20% of our total usage by core hours in GCE. And we went and calculated the savings from what customers would have had to spend if they were using the next up standard size. And it turns out those customers that are using it are saving about 19% on average, simply by not overbuying. So finally, I want to talk about fairness. So one of the things we talk a lot about with discounts is the number. What's the percentage? And there's a bunch of numbers flying around. Some are larger, some are smaller. One of the things I want to take a minute to stress is that the discount is only one part of the equation. Don't be fooled by a larger number. I'm sure we've all seen the commercials where there's 20% off a sofa, but if the sofa was marked up 4,000% in the first place, you might be better off with the guy down the street that's offering a low everyday price. So it's a little bit like that. You need to look at factors like, what's the list price? What kind of flexibility are you giving up to get the discounts? What kind of strings are attached? And are you paying for hidden things that you don't actually need? And more often than not, what we find is when people do that whole calculation, Google comes out ahead in terms of what you save by default and what you can save by making optimizations to your usage. So in 2014, when we launched Google Cloud Platform, we introduced a new way to bring discounts to customers. And we think it's a better way. So when you use our VMs consistently, it's more efficient for us. And we think our principle of fairness means that when we save money because you're using our cloud in a way that's more efficient for us, you deserve to get that back. So that's what sustained use discounts do. And the nice thing about that is that you still maintain all the flexibility of an on-demand cloud. And you can start and stop your instances whenever you want. You can change your usage pattern. It's all up to you. And we'll just give you the best discount that your usage qualifies for automatically on a month-by-month basis. So one detail I want to mention here is that there's actually two modes of calculation for a sustained use discount. And if you want, you can call them SUD 1.0 and SUD 2.0. The first is the original sustained use discount that we launched, which uses a concept called inferred instances. And I'm going to talk about what that is in just a minute. The second is what we do with custom machine types. So when we launched custom machine types, the concept of inferred instances got a little complicated because with custom machine types, you can essentially have thousands of different shapes of machines. And so what inferred instances does is it combines together usage of same shape. But now with custom machine types, you won't have same shaped. So what we do instead is we look at the total chunk of CPUs and RAM that you use throughout the month, and we give you a similar discount for sustained usage. So just briefly, what is an inferred instance? This is something we sometimes get questions about, so I wanted to explain it a little bit more. So in this graphic, imagine that you're using some one-core VMs, and you use 5 different instances at various times in the month, as is represented on the left side in the left graph. So you use instance 1 for about half the month. Sometime about the 10th of the month, you start instance 2, and then about halfway through the month, you start 3, and 4, and 5. So on the surface of it, if you understand that sustained use discounts, the whole point is we give you more discount for the more you use it throughout the month. It doesn't necessarily look like you would get a whole ton of discount because none of those instances are being used for very much of the month at all. They would get the first tier for 25% usage, but maybe not much more. So we didn't think that was necessarily fair because it doesn't matter much to our efficiency if you run one instance here and then shut it down for a while and then run another instance the next day that's exactly the same shape and run that for the rest of the month. So what we do is we reimagine your usage pattern. We reinterpret it to look like the graph in the middle. So you can see we've flipped the number 3 VM down. And this is just conceptual. This is a big data processing problem that our billing system does automatically for you. But conceptually, we've taken VM number 3 and flipped it down as if it were part of VM 1. And then we've aligned VMs 2 and 4 and part of 5 as if they were a second VM. And then we've left the rest of 5 as if it was a third VM. So now, this graph on the right is what we compute your discount on. And it's a much bigger discount than you would have gotten in the graph on the left. So you can see that it looks like you used one inferred instance for the entire month. And then the second instance you used for over half the month. And then the third instance you used for about a quarter of the month. So each of those will get a different tier of SUD, but it will be a much higher tier than you would have gotten in combination on the left. So this is one of the ways that we calculate what's the best deal for you. So we've had sustained use discounts in production for a few years now, and customers really like them. And they're getting a lot of savings out of them. But some of the conversations we've had is there any way you can give me a better discount? Sustained use discount, it resets every month. But many customers say to us, hey, I know that I'm going to use a certain amount of resources 100% of the time to run my website, and that's just getting bigger every month. So is there some way that you can give me a better discount if I tell you how much I'm going to use at a minimum for the whole year, or maybe longer? So that brings us to the question of a product we announced this morning called committed use discounts. So basically, the premise of the product is if you knew and you could tell Google that you were going to use a certain minimum amount of resources all year, shouldn't you get a bigger discount? Well, there's one obvious answer to that. We say yes. So how does it work? Basically, we give you the best discounts we possibly can if you agree to buy resources for 1 year or for 3. But don't worry, we don't require any large upfront payments. You can pay us monthly, that's cool. We've got $30 billion we're spending on infrastructure. We don't need to charge you all up front. Your promise is good enough for us. So what we do with that, though, is give you all the flexibility so that you can make changes whenever you want. If you decide one day that you're going to go into your application code and optimize it, and all of a sudden you find a bug and it turns out that you need 50% less compute than you thought you did, awesome. Change the instance sizes, keep on going, and you'll still get your discount. Additionally, we don't charge you any discount to get that flexibility. So some competing products, if you want to be able to convert them, you will lose some of the discount. You will not get the maximum discount, and that's not how ours works. So how much? So for predefined machine types, you'll get 37% off for a 1-year discount, for 1-year commitment. And for 3 years, you'll get 55%. And these numbers are actually a little bit higher for a custom machine type. They're 40 and 57, respectively. So the way that we make that flexible is that the whole thing is designed based on the underlying resources. So if you think back a minute ago when I was talking about sustained use discounts and how SUD 2.0 looks at the number of cores and RAM that you've used, committed use discounts are the same way. So rather than trying to predict how many machines you need of a certain size in what zone, just tell us how much CPU and how much RAM, and then you can use those in any combination. So it sounds like we're asking you to tell us more, but it's actually simpler because most customers already know that math. Additionally then, like I said, they're not tied to any particular VM shape, but they're also not tied to any particular VM instance itself. So what we do is we simply look at how much was running at every moment in time, every minute, and we take the first chunk of that and we give you a committed use discount on it. But the thing then is, whatever's above that, we still give you permanent billing and sustained use discount on all the rest. So there's no penalty to having a committed use discount as long as that is the minimum that you're going to be using, because you're still going to get the full discounts on all the rest. So if you're not sure how much to buy, start small, see how your workload is running, and then you can increase over time if you need to, and you can know that you're still getting a really competitive discount on the rest of it. So I built a little example just to show you what that looks like. Very simply in this picture, if you imagine that there's a threshold where you have a certain amount of committed use, and then above that you're getting sustained use, you can see where VM A is shut down for a while and then comes back. But what we've done is said, okay, well, for that period of time, the usage from VM E gets committed use, and then later it'll get sustained use again. And obviously this can look like a much more complex picture in reality. So finally, I want to talk about some features you can use to take advantage of tuning your workloads so that it's best configured to get the maximum savings on GCE. So the first feature is rightsizing, and you've probably seen this. We've talked about it in a couple different places. The social media had a kind of common idea when we introduced this feature is, what, are they crazy? They're telling me how to spend less money on purpose. Yes, we are. So we would rather that you optimize your infrastructure usage for what your workload actually needs, rather than trying to optimize your workload to fit in particular sized infrastructure of ours. And we would rather that you buy what's valuable to you and nothing more. We'll happily sell the rest of that to somebody else. So what this does is automatically monitors your CPU and RAM usage from outside the VM, and if it sees that you never use more than a certain amount of CPU, we'll recommend that you scale down the CPU. If you're never using more than a certain amount of RAM, we'll scale that down too. Now it turns out, as one additional detail of this, if you actually install the stack driver monitoring agent, then we get better memory information and we can actually make a better recommendation for you. But either way, you'll get a good recommendation on what kind of machine you want. And then simply, all you need to do there is on the right-hand side, click that recommendation, and you need to shut down and quickly restart your VM in order to change the size. It's just that simple. Finally, I also want to talk about preemptible VMs. So the idea with preemptible VMs is to offer a product that is as low cost as we can make it and optimized for short-term workloads. So if you have a large-scale, fault-tolerant workload that can withstand a few of its workers shutting down without losing too much of your overall work, then that's probably a job that is really ideal for preemptible VMs. And if you use those, you'll find that they're almost 80% off of list prices. In some cases they are 80%, in some cases they're a little bit less. The only restrictions are that there's a maximum lifetime on that VM of 24 hours, and there's a small probability chance that we might take back the VM early. We'll give you a short warning of about 30 seconds and say, hey, we need that back. So a lot of workloads, you can see there's a whole list of different ones below, are finding that that's a really efficient way to get large amounts of compute. So one of my colleagues in a room down the hall right now is talking about an example where Fermilab ran 160,000 cores, preemptible, in order to calculate higher energy physics experiments. And it actually doubled the compute fleet of Fermi National Accelerator Laboratory in finding exotic new physics particles. So it's just one example of what you could do with preemptible VMs in a very affordable way. But there's lots of other use cases, from genomics and genome sequencing to computational chemistry, fluid dynamics, et cetera. So finally, I want to talk a little bit more about our autoscaler. I showed the graph earlier that talked about how permanent billing helps, but there's actually some other features of our autoscaler that help save money too. So first of all, the fact that it's extremely fast and reactive to workloads. So unlike some other autoscalers, we've actually never had to consider building a feature where you would either schedule in advance for it to scale up or pre-warm VMs so that it could react faster. We kind of feel like that's not what auto is supposed to mean. So ours just scales. And because our VMs can boot in 30 seconds or less, we can actually react to spikes very quickly, up to millions of QPS. And what that means is you don't have to have VMs sitting around waiting or running longer in case the spike comes back. You don't have to have them running just in case there's a spike, because you never know what might happen on social media. You don't have to worry about any of that. And all of those VMs that might be running handle scenarios like that are just money you're wasting. So just the fact that our autoscaler works like this actually saves you money as well. And you might even actually consider whether workloads you might not think are web servers, for example, those workloads might benefit from a fast autoscaler and help you automatically tune what you're using. So that's a number of the different pricing features and discounts that are available on GCE. And now I'd like to invite Michael Crandell, who's the CEO and founder of RightScale, up to show you what some of that looks like in practice. Michael? Thank you.
Thanks very much, Paul. You know, I wanted to start out by sharing it's a pleasure to be here. It's especially exciting during this week of pretty actually groundbreaking announcements about pricing and innovative announcements. And I just wanted to share that maybe for those of you here and those online, it's those of you who are, it's late on a Thursday, it may be that savings in cloud spend is not the most exciting thing, but I can share with you that I guarantee the more you use cloud, and we hear this all the time, pretty soon as you start getting those bills, savings becomes a lot more interesting in your organization. And so I promise that this is going to be meaningful stuff. Little background about us. At RightScale, we focus on cloud management. And ever since about 5 years ago, we acquired a small startup that was focusing on a piece called Cloud Cost Management, Cloud Cost Analytics. We've seen increasing interest in both the opportunity that can be achieved through savings and the challenge. And so let's dive right in on the challenge side. We also run every year a State of the Cloud survey. We get about 1,000 responses from companies ranging from small businesses to enterprise-level companies. And we ask a bunch of questions, and we ask one about waste. What do you think you're wasting in your cloud spend? I think Herzl shared that this morning, this stat, but the self-reported waste, in other words, the waste that people think that's occurring, is about 30%. We've found from our product and in close engagements with customers that often is upwards of 40, up toward 45%. So it's pretty clear, everyone agrees there is a lot of waste, and that also means there's a lot of opportunity. So I wanted to share with you today, from RightScale's perspective in the field, 3 of the biggest areas that we see that are waste out there and that are also opportunities for savings. And they focus around these 3 areas. One is not taking advantage of discounts, discount structures that are available. The second is running workloads that don't need to run all the time and still running them 24/7. And the last area is over-provisioning, right? Underutilized instances and VMs that are running out there. And so we'd like to focus across these 3 areas on 3 of the feature offerings that you've heard about today, some of them brand new offerings, committed use and sustained use discounts, preemptibles, and custom machine types. So let's launch in first on the first use case, which is optimizing and taking full advantage of discounts. Starting point there, most of us are familiar with what's probably the oldest and most familiar discount scheme out there. It's from Amazon Web Services, called reserved instances. And many of you may be familiar, but just quick refresher, there are many types of these, but to start with standard reserved instances, you basically, in order to get a discount, you pick a specific size of instance in a specific instance family in a particular region and commit to either a year or 3 years to gain that discount. And they also have a family of RIs called convertible RIs. And it's important to note the discount is lower there and it's only available with a 3-year commitment. So what we find among customers in this RI world is actually a lot of resistance. People struggle with this. And the reason they struggle with it is pretty simple. It's because they're being asked to predict the future, and quite often the workloads that they're dealing with, the apps that they're dealing with, and the approaches they're taking to development, test, and production in the cloud aren't that predictable. And so you see some of the reasons listed here. I'm not sure if I might change architectures. We're not sure what might happen to the utilization of our app. There may be new types of instances coming with bigger discounts. So there's fear of making a commitment that you're not going to fully use, and there's a lack of flexibility that causes hesitation. So the reality is really that in many apps and many workloads, you're actually dealing with constant change. The approach to development and test, etc., is evolving. Your architecture is changing and evolving. You're not sure what your needs will be. And we've often asked ourselves, wouldn't it be great if we could get the discount but not be locked in to these specific instance size commitments? And here's an example of that. It's just a hypothetical example of, I think it's 5 instances on the left. Maybe in the future, what you're using now needs to change to that 8 instance model, where in this case, you're using smaller instances and distributing the workload more. Wouldn't it be great if you could get that? Well, actually, this is just another description of what's been announced this week with committed use discount. And again, you can get some of that with convertible RIs, but you're committed to 3 years, which in our experience is really quite a long time frame for most customers. Let's take a look at a specific example. This is an anonymized real customer usage with cost on the vertical and over time on the horizontal. And you can see that there's a pretty steady base usage there that's growing slightly, and then during weekdays, some transient usage. That's dev and test in this example. So if we map this to both providers, comparing AWS and Google, on the AWS side, what we would recommend, and we happen to know this customer is using about 80% of those instances are production and about 50% for dev and test. We would recommend, if they're having to lock in and commit to standard RIs, we'd say, why don't you limit your exposure there to 65% in order to gain savings, but leave yourself some flexibility for change. If you're going to commit to convertible RIs, go ahead and go up to 90%. So that's what our recommendation would typically be over a long experience helping customers save money. Take a look at that on Google. With Google pricing, it's pretty much a no-brainer with the new committed use discount. Just go ahead and take 90% of it and buy into that with a committed use discount, because there's no flexibility trade-off. And let the sustained use discount with the inferred instance capability that Paul mentioned earlier take care of the rest. That's going to automatically fit the pieces together of the transient uses into the most optimal cost savings for you. If we map that onto actual dollars, what you see here, we've done the calcs for you. I'm not going to go through every detail there, but we did map out 3 different levels with the assumptions that I mentioned about 50 and 80% averaging out. So a standard RI 1-year reserved instance approach, on the right-hand side, you can see you're getting 21% savings by using that mechanism. 3-year standard RI, 39%. And the more comparable 3-year convertible RI is 34%. So what we're going to look at here to keep it apples to apples and try and match some of the flexibility in the Google pricing scheme that allows you to shift instance sizes and families and so on. We're going to map the first one, which is a 1-year, and the third one, which is a 3-year convertible. Here's what that looks like on Google. 35% on the 1-year, which represents 28% better savings than the AWS 1-year standard RI approach in this example. And then on 3-year, 52% savings, which represents a 35% improvement over AWS 3-year convertibles. If you summarize all of that into a single chart, here's what you're looking at. On 1 year, you have better pricing. On 3-year, you have better pricing than both the full 3-year without convertible and the 3-year with convertible. And other important points to remember is that on the 1-year, you still, with committed use, you still get flexibility. So that's an advantage on flexibility, whether it's 1-year or 3-year. You also get more ease of use, because it's important to remember with the convertible RIs on AWS, you still need to track your usage and make a special request to AWS to assign an instance to the convertible RI you've bought. In the Google scheme, all of that happens automatically. And then, of course, the final and third point is it's just less expensive. So we think that's pretty groundbreaking and pretty compelling. Second use case was dev and test workloads. So this is a starting point. We are talking about savings here, and this doesn't really apply to one cloud or another. This applies to any cloud that you run on. And actually, I'll admit, might be obvious to you, it was a little bit of an eye-opener for me years ago when I first looked at it. If you limit your usage on your workload to only, say, 12 hours a day, 5 days a week, you're actually saving 65%. And that's a key thing that we help people with automation in the rest of the RightScale platform, is to schedule runtimes that don't run 24/7 when they don't need to. Paul mentioned a whole bunch of workloads. I think one of the most common is dev and test that we're talking about here. So when we map that to the preemptible model that Paul talked about, we've got 4 levels there. If you run with sustained only, you see the first price around $67,000. If you commit to a portion of that, you can achieve a 9% savings with the committed use discount. If you start mixing committed with preemptibles, and if you can have a dev and test workflow that is tolerant of instances being taken away, and maybe it's just the loss of a little time for you versus loss of any data. If your dev test flow allows for that, which means think about that, that's a good thing. You could save 40% by splitting half and half, and if you're able to put all of that dev and test onto preemptibles, it's a 70% savings. So there is an analog here with Amazon's spot instance market. Difference being that in that market, it is a market and you need to bid, and so you're not guaranteed a price. You can get pretty great savings, but here you're guaranteed a price. You know what you'll be paying in this model. The last use case I wanted to share was around rightsizing using custom machine types. This is a screenshot of a part of RightScale on cost analytics that we call the utilization report. And what you see here along the horizontal axis is how much memory utilization there is on an instance. So farther to the right, more memory. Farther up vertically on the graph, more CPU utilization. The instances or VMs are represented by the circles, and the size of the circle is the cost that you're paying for that VM. So immediately, with a single blink, your eye can go to the lower left and go, I'm paying for stuff that I'm not using there. And that's pretty great to be able to see. Now, sometimes that's on purpose. For example, you might have a warm spare, hot spare sitting there for some sort of disaster recovery scenario. So it might be on purpose, but in many cases it's not. And when we work with customers, we say, in that very lower left, that's a candidate for downsizing a t-shirt size or two with the standard predefined VM types. But more importantly, when we're talking about custom machine types, in the upper left, that's an example of VMs where the CPU utilization is pretty reasonably high, but not the memory. So you might want to dial in a custom machine type that lowered the memory requirement. Same applies in the lower right, just the converse, high memory utilization, low CPU. So here's another example. Let's say you needed 4 CPUs and 20 gigs in a machine size. Standard predefined VMs on both AWS and Google, you'd have to get an 8 CPU and 30 gigabyte, and you can see what the pricing is there. And I think that Google pricing is updated for the announcements this week. But if you're able to dial in a custom VM in this example, you save even more. You're able to save 42% over the standard predefined size on Google and 64% over the standard predefined size on AWS. So that's a quick tour of these three approaches to savings. And I think the bottom line is that with the announcements you've heard this week, as well as other mechanisms Google's had in place for pricing, they've pretty much upped the ante and taken the lead in the cloud provider space for offering very customer-friendly pricing. So we'll just say compliments to the whole Google Cloud team. We're very impressed with that, and thank you for making all of this a whole lot easier for us customers out there. By the way, if you're interested in learning more about RightScale, and Paul, why don't you start coming back up here too, because we'll do some Q&A. We do have a booth here downstairs. We also are doing a webinar, I think the two of us together later this month with a deeper dive on March 23rd. You can also get that State of the Cloud report that I referred to earlier off of our website.